In lesson 1.1, we're going to be looking at graphs of equations. Now, you don't have to memorize special tricks on how to make graphs. You can always make a table of values and then plot those ordered pairs in a coordinate system to make your graph. So let's look at example 1 where we've got x squared minus 2. We're just going to make a table of values. We're going to have a list of inputs, x, and outputs, y. And you really can decide what you want to plug in. Let's plug in some negatives and some positives. And I'm going to pick some small, easy numbers. So if I plug in -2, then I'm looking at my function. It wants me to take the x, square it, and subtract 2 from it. So then the y value would be 4 minus 2, which is 2. If I plug in -1, I get 1 minus 2, which is -1. If I plug in 0, I get -2. If I plug in 1, I get -1. And if I plug in 2, I get 4 minus 2, which is 2. So now I've created these ordered pairs. -2, 2, -1, -1, 0, -2, 1, -1, and 2, 2. And then what you can do with those is then make a graph. So you've got your x-axis and you've got your y-axis. And then we can mark this. We went over 1, 2, -1, 2. We're getting values that go up 2 and values that go down 2. And then we can plot these ordered pairs. So -2, 2 would be left 2, up 2. -1, 1 is left 1, down 1. 0, -2 is 0 and then go down 2. 1, -1 is over 1, down 1. And 2, 2 is right 2, up 2. Plot those points and then we can connect them. Since this is squared, I know it's a parabola. So it's going to be rounded like that. In example 2, we're finding x and y intercepts of a graph. So when we look at an equation, if you want to find the y intercept, which is where it crosses the y, then the x value would be 0 on that graph. So you can plug in 0 for x. So basically, when you're looking for x and y intercepts, you are going to plug in 0 for x to find a y value, the y-intercept, and you're going to plug in 0 for y to find the x-intercept of the graph. So now, if I plug in 0 for x, that would be 0 cubed minus 4 times 0, which is giving me 0 minus 0, which is 0. So I've got a y-intercept of 0. And that just answered the other part for me. Oh, but I might have more than one. So what we're going to do is, now we're going to plug in 0 for y. I'm going to do that somewhere else. Plug in 0 for y to find the x-intercept. Now on this one, we're going to need to factor the right side. They each have an x in common, so I'm going to factor out an x. And then if you want to solve from there, or you can factor further. So you can set this equal to 0, and then you can set this equal to 0. So you can either factor that into x plus 2, x minus 2, and set each of those equal to 0, and you get -2 and 2. Or you could add 4 and take the square root. And just remember, you get plus or minus when you take the square root. So I'm getting 3 x values when I plug in 0. So I'm getting 0, -2, and 2. So that would mean that my y-intercept is 0, 0. The y-intercept is 0. And then the x-intercepts, there are 3 of them. We've got, it's crossing x at -2, 0. It's crossing at 0, 0. And it's crossing at 2, 0. So now if you want to pause the video and see if you can do it on your own, try part B on your own. And if you need help, let's do it together. So we're going to plug in 0 for x to find the y and 0 for y to find the x. So if I plug in 0 for the x, I get y squared equals 4. And I'm going to take the square root of both sides. So I'm going to get y equals plus or minus 2. If I plug in 0 for y to find the x-intercept, I'm going to get 0 equals x plus 4 and subtract 4 to the other side. So x equals negative 4. So it looks like I'm getting two y-intercepts at 0, negative 2 and 0, positive 2. And I'm getting one x-intercept at negative 4, 0. So that is how you find intercepts. Right, now we're going to talk about symmetry. Symmetry in the equation and symmetry in a graph. So if it's x-axis symmetry, then your graph, when you look at it, is going to be some sort of graph, say like this. Oh, that's ugly. Where whatever is on top is a mirror image of what's on the bottom. So it is symmetric over the x-axis. If you've got y-axis symmetry, same thing, but you're going to have that on the x, or I mean on the y-axis. So whatever's on the right is a mirror image of what's on the left. And then if you've got origin symmetry, it's both. It's both x and y. So let's say, but it would need to go through the origin. So well, not always. So I take that back. It doesn't have to go through the origin, but the symmetry is through the origin. But let's say I've got this right here as my starting point. If I reflect it over the y, it'd be here. Remember I said it would be both. So now I'm going to reflect that over the x. And that is what it looks like. So it's kind of diagonal quadrants, if you want to think about that, or you can think about it as being reflected over the y and then over the x. So how are we going to test for this? If we're just given an equation and we don't want to graph it. So if you're looking for x-axis symmetry, then you can replace your y with a negative y and get the same value. So replace y with negative y, and then you get the original equation back. Okay, we do the same thing with y-axis. If I can replace x with a negative x and get original back, then it is symmetric over the y-axis. And then if I can replace both, and get the original back, then it's symmetric over the origin. So let's test this one for symmetry to see what I'm talking about. So we're going to take y equals x squared minus 2, and we're going to change y to negative y and see what that does. We're also going to replace the x with negative x. And then let's replace both. And usually when I replace something, I put parentheses around it. Okay, so in the purple one, where we only replaced the y. So I'm testing for x-axis symmetry here. So if I want to solve then for y, because I'm trying to get back to the original, I would have to divide the negative to the other side. So that's going to give me negative x squared plus 2. And we notice that that has changed. So it does not have x-axis symmetry. Over here, the negative was substituted in for the x, but when you square this, the negative goes away, so you get positive x squared minus 2 when you simplify it, which is the original. So we do have y-axis symmetry. And then for origin symmetry, if I simplify this one, I'm going to have negative y, we squared that, it's going to be positive x squared. Divide that negative to the other side because I'm trying to get y to be positive. And I get it's different than the original. So it does not have origin symmetry. Okay, example 4, we're going to sketch a graph of this function using a table, just like we did in example 1. Now, if you don't recognize this is an absolute value function. So let's talk about what absolute value actually means. An absolute value function is actually called, or it's a piecewise function. And what it does is it says that you've got 3 cases. Either x is negative, which is less than 0, or x is equal to 0, or x might be positive. So think about that for a second. Those are your only 3 cases. That has to make sense, that x either is negative, it's 0, or it's positive. Okay, so if that's the case, the absolute value, if x is negative, it turns it positive. So how do you take a negative number and turn it positive? You put another negative on it. So that's a negative x, which is a positive. What if x is 0? Then the absolute values is just going to keep it 0. And what if x is positive? Then the absolute value does nothing, so it just leaves x alone. So that's the actual piecewise definition of an absolute value. Now let's look at just using a table of values. We're going to make a x and y table. I'm going to plug in some negatives and some positives. Now remember, y is absolute value x minus 1. So what we're going to do is we're going to do the inside first. And then we're going to take the absolute value. So yeah, let's just do that in pieces. So it would be negative 2 minus 1, negative 1 minus 1, 0 minus 1, 1 minus 1, and 2 minus 1. Okay, now let's evaluate those. Negative 2 minus 1 is negative 3. Negative 2, negative 1, 0, and 1. Now let's evaluate the absolute value. So when you look at the negatives, those fall into this category where the x's are negative inside, and so we just add a negative in front to get rid of the negatives. So in other words, negatives become positive. Oh, there's 3 of those. So that one also. Then let's look at the 0. We've got 0, which would be this piece of the piecewise function. If you've got 0, it just stays 0. And then you also have a positive, which would be this third piece. If you have a positive, it just stays the same number. It stays positive. So those are your values. And it says sketch a graph. And if you remember graphing these in Algebra 2, they do make a V shape. So we've got, you can think of these as ordered pairs, negative 2, 3. Plot a point. Negative 1, 2. Plot a point. 0, 1. Plot a point there. 1, 0. That's right 1, up 0. and then 2, 1. That's right 2 up 1. So you can see this does make a V shape. It's just off